Now let us study the complex cube roots of unity, that is nothing but the complex cube roots of number 1. So here basically we want to find out what is the cube root of 1. So it is 1 raised to 1 by 3. So in other words, if we cube both sides, we get x cube equal to 1. Now we already can readily find out that x equal to 1 is one of the roots, but then it still leaves two other roots to be found out. So which is what we are going to do now here. Now taking 1 on left hand side, we have x cube minus 1 is equal to 0. Now this is of the form a cube minus b cube. So therefore we can factorize the left hand side as x minus 1 into x square plus x plus 1 is equal to 0. So this implies that either x minus 1 is equal to 0 or x square plus x plus 1 is equal to 0. Now if we consider x minus 1 equal to 0, then we get x equal to 1, which is obviously one of the already known roots of the cubic equation x cube equal to 1. Now let us study the other quadratic equation because it is going to give us two remaining roots. So if we consider x square plus x plus 1 equal to 0, by the formula we have x is nothing but minus 1 plus or minus, we have b square, that is 1 square minus 4 into 1 into 1, that is b square minus 4ac whole upon 2a, which is 2. So that we have minus 1 plus or minus square root of 1 minus 4 whole divided by 2, which is equal to minus 1 plus or minus square root of minus 3 whole upon 2, which in turn gives us minus 1 plus or minus. Now square root of minus 3 can be written as root 3 times I, because minus 3 is 3 into minus 1 and whole divided by 2. So here we get the two remaining roots of the given cubic equation, as we have plus or minus sign that gives rise to two different roots. So we call them as, say, alpha and beta. Now if you see, they are the complex conjugates of each other because the sign of the imaginary part is just exchange in both of them. So these three together are called as the cube roots of unity, and the last two roots, that is alpha and beta, which we obtained, they can be called as the cube roots which are not purely real because they contain the imaginary parts. Now let us go over quickly the properties of these cube roots of unity. Now many times the cube roots alpha and beta can be denoted in general by the symbol as omega. So let us see the properties of these cube roots. Now if omega is the complex cube root of unity, then 1 plus omega square is equal to 0, because it directly comes from the fact that we had solved the quadratic equation of x square plus x plus 1 equal to 0, and the root of this quadratic was nothing but omega, so therefore it must satisfy this particular quadratic equation. So therefore we have this particular first property. It is very important because it can simplify the long complicated expressions involving omega. Now the second property says 1 plus omega raised to k plus omega raised to 2k is equal to 0 if k is not a multiple of 3, but it is equal to 3 if k is a multiple of 3. Now this also directly comes from the fact that omega cube is equal to 1, because omega is nothing but the cube root of unity. So therefore if k is a multiple of 3, then it automatically means 2k is also a multiple of 3. So therefore each of the term on the left hand side is nothing but equal to 1, because that can be expressed as some power of omega cube. So therefore we have the second property. Now the third property says that the conjugate of omega is equal to omega square. Next we have the reciprocal of omega, that is 1 upon omega, is equal to omega square. And lastly we have the product of omega and conjugate of omega is equal to 1. So these are the typical properties of complex cube roots of unity.